Okay. So Shiloh, you've got some lenses in your hand, and we've got a light box right down here.
Hey, Dad, look. It's a puzzle piece.
It does look like puzzle pieces. So let's take a look at, first off, let's look at this lens right here. Do you know what kind of lens this is?
Huh.
It's a convex lens. We have a lens just like this in our eye. So could you take the convex lens and stick it in front of the beam of light? And look what happens to the beam of light with the convex lens. They get bent inwards. So here this red is actually refracting and then bending up, and the blue is refracting down. The green's kind of going straight through, but this point right here where all the light rays meet, that's called the focal point. And since we have one of these in our eyes, the back of our retina is right around here, just past the focal point. So everything we actually see is upside down. So you see how the blue right here would actually be at the bottom, and the red right here is at the top. That doesn't mean our world is upside down, but the things that we see are upside down, and our brain has been trained to flip it right side up. You'll find lenses like this in things like telescopes. And so technically everything you see in a telescope is upside down as well, as long as it's a refractor telescope. This next kind of lens, Shiloh, can you move this next kind of lens for us? This next kind of lens is actually called a concave lens. It's concave because if you look at it, it's caved inwards towards the center, and it's caved inwards here. And look, it actually spreads the light out. Instead of having a focal point at this end, the light is moving outwards. So if we bend it a little bit, you can see it changes. There's a little bit of internal reflection going on right here, and it bends that upwards. But this would be an example of a concave lens. There's just not many uses for concave lenses. And just as a quick review, let's go back to reflection. And if we're reflecting things in a straight line, this is called specular reflection, not diffuse reflection. This is specular reflection. So it's kind of fun to use these light boxes in order to demonstrate reflection, refraction, and lenses. That's all. Was that kind of fun, Shiloh? You like that? All right, bye. One more thing I want to show you that I think is worthwhile is if you look at these three light beams, we've got red, green, and blue. These would be the primary colors. And when we put the primary colors together, look what it makes. We have white light. So we put the three primary colors together. So ironically, you put three colors together and you get white. It's the opposite of art. In art class, you put the three primary colors together and you get black. But in science class, you put the three primary colors together and you get white. I just thought that would be fun. Yep, we got white again. Tons of fun. All right, we got to roll.